Let's review what we have done in the course so far. We started with the meaning of average rate of change of a function when x is between a and b, which is the slope of the secant line joining the endpoint of the interval. Average rate of change of a function is rate of change of a function over an interval. Average rate of change of f of x when x is between a and b is f of b minus f of a over b minus a. We used the average rate of change and defined instantaneous rate of change as a limit. We have a point, we pick a point x close to the given point A, we create an interval, and eventually we say when the length of the interval approaches 0, average rate of change becomes instantaneous rate of change. By definition, average rate of change of f of x at x equals a is limit of f of x minus f of a over x minus a as x approaches a. It's also can be written as limit of f of a plus h minus f of a over h as h approaches 0. This limit is called derivative. Therefore, the meaning of derivative and instantaneous rate of change at the point are the same. The geometric interpretation of derivative at the point is the slope of the tangent line to the graph of the function at the point. We used definition of derivative f prime of x equals limit of f of x plus h minus f of x over h as h approaches 0, which is also called first principles, and we developed this table to find the derivative of functions. Derivative of a constant function is 0. Derivative of a linear function is the slope of the line. Derivative of axn when a is a constant is an x to the power of n minus 1. N can be any real numbers. We proved it for when n is integer, but it can be proved that n can be any real number. Derivative of addition subtraction of two functions is addition subtraction of their derivatives. We proved it for two functions. It can be proved for as many as functions that we can have. Derivative of a constant times a function is constant times derivative of a function. Derivative of product of two functions is derivative of the first function times the second function plus derivative of the second function times the first one. Derivative of a ratio is derivative of numerator times denominator itself minus derivative of denominator times numerator divided by denominator to the power of 2. And derivative af of x to the power of n is an f of x to the power of n minus 1 times f prime of x. This is called quotient rule. The derivative of ratio is called quotient rule. Product rule is when we use product of two functions. And this one is called power rule. Sometimes this is called also power rule, and they refer to this as extended power rule. Let's have a couple of examples. This is the notation that we used so far for derivative of y equals f of x. There is another notation which is called Leibniz Notation, dy dx, the derivative of y as dependent variable with respect to x as independent variable. Derivative of y equals 9x5 plus 6x5 minus 9x3 plus 2x2 plus x plus 1. dy dx is 30x4. 6 times 5, 30. 5 minus 1 is 4. 30x4 minus 27 x to the power of 2, 4x, 2 times 2, 4, 1 less than 2 is 1. Derivative of x plus 1 is 1. Derivative of mx plus b is m. Derivative of 1 over x7 plus x cube root of x. This can be written as x to the power of negative 7 plus x to the power of 1 over 3, which is negative 7 x to the power of minus 8 plus 1 over 3 x to the power of negative 2 over 3. It can be written as negative 7 over x8 plus 1 over 3 times cube root of x2. Example 3, derivative of 9 times x2 plus x plus 5 to the power of 8 times 2x plus 7 to the power of 9. It is product rule. You have two functions here. Derivative of the first function is 8, and we have to times it by 9, 72. x2 plus x plus 5 to the power of 7 times 2x plus 1. This is the derivative of the first function times 9 times second function itself plus derivative of the second function. You have to times it by 9. 9 is a constant. 9 times 2x plus 7 to the power of 8 times 2 times the first function, which is x2 plus x plus 5 to the power of 8. Example 4. Find instantaneous rate of change of y with respect to x when x is 2 and y is x3 minus 2x. We find the derivative of the function dy dx equals 3x2 minus 2. Instantaneous rate of change at the point is derivative at that point, which is 3 times 2 to the power of 2 minus 2, 10. Next question is example 5. Write the equation of the tangent line to the graph of y equals x3 plus 2x minus 3 to the power of 4 when x is 1. The contact point is 1, and we plug in 1 to the function, we get 0. The derivative of the function is 4 times x3 plus 2x minus 1 to the power of 3 times 3x2 plus 2. Derivative of, we used power rule or extended power rule, n f of x to the power of n minus 1 times f prime of x. F of x in this case is x3 plus 2x minus 3. We use this formula. N is 4, a is 1. There is no coefficient, so it's going to be 4 times f of x to the power of n minus 1, x3 plus 2x minus 3 to the power of 3, times f prime of x, which is 3x2 plus 2. If we plug in 1 into the derivative, slope of the tangent line would be 0. Therefore, the tangent line at this point is horizontal. Y minus y1 equals m times x minus x1 is the equation of the tangent line, which is y equals 0. Thank you.